Hi friends! Today we will learn what is secondary succession, so let's start. Let's first revise what we learned about succession in our last section. We know succession is the orderly, natural, stepwise development of various species of ecosystem and their dependence that forms a complex interlinked ecosystem. Succession involves very gradual and continuous changes that results in the formation of new species in the environment and lead to the extinction of previously existing weaker species of plants and animals, or they are no longer adapted to the current conditions in the environment. Plants play a very important role in succession, as they are the source of food and shelter for various species of animals in the ecosystem. The environment conditions gradually change to become ideal for new species rather than pre-existing ones, and succession goes on. Succession is of two types, primary succession and secondary succession. Primary succession happens in an area where there were no life before. We learned about primary succession in detail in our last section. And it was the slow process of growth of an ecosystem from a new substrate, that is land with no vegetation, no organisms, and not even soil. For example, an area such as lava flow, or an area left after a retreated glacier. Now we will be learning about secondary succession. Secondary succession starts with an event, for example, a forest fire, harvesting, hurricane, so on and so forth. It reduces an established ecosystem, for example a forest or a wheat field, to an area with very few or no living organisms, but soil already exists there, as opposed to primary succession. I repeat, in the case of secondary succession, it begins with an event, for example a forest fire, harvesting, or hurricane, that reduces an established ecosystem, for example a forest or a wheat field, to an area with very few or no living organisms, but soil already exists there, as opposed to the primary succession. And in primary succession, not even soil exists when the primary succession begins. So in other words, secondary succession starts when an established ecosystem is disrupted by some natural calamity, but some primary requisites to start life, like soil and some species of plants and animals, already exists there, and it is usually faster than primary succession. As soil is already present, seeds, roots, and underground vegetative organs of plants may still survive in the soil. Now let's have a look at an example of secondary succession. A pre-existing forest that catches fire, and that fire burns the forest to the ground. Now, soil exists there, seeds are still buried, and microorganisms still live there. So, grasses and other herbaceous plants grow back very fast. Small shrubs begin to grow, and then small living organisms like earthworms, insects, birds, snakes, frogs, ants increase in number. Gradually, trees grow back too, and shade-intolerant species of plants die out, and shade-tolerant small trees and shrubs keep growing. Animal and birds that feed on the existing plants and animal species grow in number, and this way the whole forest will be back. And this is how secondary succession takes place. And the pioneer species are replaced by intermediate species, and intermediate species are replaced by climax species. Now I know you want to know what is the meaning of pioneer species, intermediate species, and climax species. Let's first learn about pioneer species. They are the species which are the first to colonize in the ecosystem when there is no life existing previously. Examples are lichens grow on rocks, even without soil. And later on, they gradually break down rocks, and soil is created with these broken pieces of rocks, and the dead remains of lichens themselves. And the first plants that grow on the freshly prepared soil by lichens are known as the pioneer species of plants. Let's learn the special adaptations of these pioneer species of plants that grow first. Pioneer species of plants are always photosynthetic. As no other source of energy is available, they use the energy of the sun to prepare their own food. They have nitrogen-fixing bacteria in their root nodules for fixing nitrogen for them. They have long roots to fetch water deep beneath the layers of rocks. They are wind-pollinated as no insects are there to pollinate them. So lichens and these plants with special adaptations are among the first species that form life on an area with no signs of life. The remains of these pioneer species help in making more soil and nutrients for upcoming species of plants and animals. Here we have some examples of pioneer species of plants and animals. Barren sand or lime grass, sea couch grass, marram grass, salt water or green algae, marine eelgrass, pickleweed, cordgrass, Spartina anglica, clear water, algae, mosses, freshwater eelgrass, bare clay, orchids, mountains, lichens. Now let's learn about intermediate species. The specific species that create connecting links between the fossil record of life and today's life forms the intermediate species of life. All forms of life are in the continuous mode of evolution, so we can say every species is an intermediate species. These species help to demonstrate the gradual process of speciation and evolution. Now let's learn what are climax species. Climax species are the species that will remain almost unchanged for as long as its habitat remains undisturbed. For example, the most shade-tolerant trees that establish in the process of forest succession are the climax species. They will remain almost unchanged. Only a disturbance to their habitat, like a forest fire or a volcano, may kill the climax species. And there again begins succession that leads to the growth of climax species. So pioneer species are the opposite of climax species. Succession begins with pioneer plants, and succession ends with climax plants. Climax species are mostly found in dense forests or fully established ecosystems. Now let's have some examples of pioneer species. Douglas fir, paper birch, white spruce, maple and oak trees. These are some examples of species well adapted to mature communities or the last organisms that show up in the succession. So these are climax species. So now we know what is primary succession, what is secondary succession, what are pioneer species, intermediate species, and climax species. Now let's learn some differences between primary succession and secondary succession. First of all, primary succession starts at the place where there is no soil, so it starts with the formation of soil. Whereas secondary succession, soil and some life forms are already present when the secondary succession begins. And secondary succession is faster than primary succession, as seeds, roots, underground vegetative organs of the plants are still present in the soil in case of the secondary succession. For example, primary succession occurs on volcanic land, and secondary succession occurs after a forest fire. In primary succession, lichens and mosses come first. In secondary succession, seeds and roots of the plants are already present. They just grow like lichens, and mosses grow first in primary succession. And grasses are the first to grow in the case of secondary succession. So these are some differences between primary succession and secondary succession, and the similarities are both results in climax species and climax community. Both results in shrubs and trees. Both take a long time to occur. So friends, today we learned about secondary succession and some differences and similarities between primary succession and secondary succession. You may now go ahead and take a quick. Thank you so much for watching. Don't forget to like, comment, and share this video. And if you want to see more fun videos, you can hit that subscribe button. You can also follow us on Facebook and Instagram for more content. Bye-bye!